Hello and welcome to another past paper session. Today's paper is uh, May, June, and paper 1, variant 1 1. Okay, no, so sorry, May, June, it's October, November. Okay, so there's a typo in the title. This is October, November 2024, variant 1 1. Okay, I will fix the title if I can. Just wait. I think I have fixed. Okay, beginning with the first question. This is in the expansion of kx plus 2 over x power 4, where k is a positive constant. The term x independent of x is equals to 150. So I am looking for a particular term. So that's what I'm going to do. I'm going to say NCR kx power 4 minus r 2 over x power r. Find the value of k and determine the coefficient of x square. So let's first take powers of x and equate them to x power 0. So x power 4 minus r equals to x power 0. So 4 minus 2r equals to 0, r equals to 2. So 4c2 kx power 4 minus 2 and 2 over x power 2. The term should equal 150. Okay, so 4c2 is 4 into 3, 12, 6. K square x square into 4 over x square. That gives me 24k square equals to 150. So k square is therefore 150 divided by 24. 25 over 4 is a positive constant, so there's going to be just one value, 5 over 2. Then I want to determine the coefficient of x square, so I'm going to again start the process and say that x power 4 minus 2r should equal x square, 4 minus 2r should equal 2, and r should equal 1. Then when I want to find out the coefficient, I'm going to say that this is k is 5 over 2, x power 4 minus 1, 2 over x power 1. Okay, okay, then I get the coefficient. So 4 into 2.5 cubed into 2. That gives me 125x cubed over x. I just want the coefficient, so my answer is going to be 125. I'll make a box over it to indicate that that's my answer. That was my other answer for k. Okay, that's question number 1. Question number 2 says the curve y equals to x squared minus a over x has a stationary point at minus 3b. So this is a question on differentiation. So dy by dx equals to 2x, and this was ax power minus 1, so plus ax minus 2. Okay, I have the stationary point at minus 3 comma b, so when x dy by dx is 0, x is minus 3, find the values of the constants a and b. Minus 3 power minus 2 gives me minus 6 plus a over 9. A equals to 54. So 54, A is 54, B, and then I have to find B. I'm going to use that in the equation of the curve, and I'm going to say that B equals to minus 3 squared minus A over minus 3. Okay, I have A, so I'm going to plug that in as well, 54. Okay, so B is therefore 9 plus 18, B is 27. Okay, moving on to the next question then. Question number 3, it says the diagram shows a sector of the circle AO where OB equals to OC equals to 15. The size of angle BOC is 2 over 5 pi radians. Points A and D on the lines OB and OC respectively are joined by an arc of AD of a circle. So that's a very small arc. Let's call that that angle should be something. The size of the angle BOC is 2 pi over 9, pi over 5. Okay, the shaded region is bounded by the arcs AD and BC and by the straight line AB and DC. It is given that the area of the shaded region is 2 over 9 pi. Okay, find the perimeter of the shaded region, giving an answer in terms of pi. Okay, so first what I'm going to do is I'm going to resolve this crisis where I need to know that what is the radius of this circle, this sector basically. So area of shaded region would have been, area of shaded region is given as 209 over 5 pi, going to be large sector minus small sector. Large sector is half r square theta, half r square, that's the small radius, theta. I see pi is common in all of them, and so is the denominator 5, so I'm just going to get rid of that. Okay, so half 15 square minus r square is equals to 209. 209 times 2 is 418. Okay, there were 2's as well, so that's 2. That's 15 square minus r square equals to 209. 225 minus r square equals to 209. 225 minus 209 is 16. So r should equal 4. Then I have to find the perimeter of the shaded region. So perimeter is going to be the large arc plus small arc, and then the two sides. So the names of the two sides, the names of the two sides are AB and CD. They're both 11 centimeters. Small arc is S equals to r theta. So 4 into 2 pi over 5, and large arc is 15 into 2 pi over 5. Plus 8, 38 pi over 5 plus 22. Oh, those are the correct answers. Yes, those are again correct. Move on, let's see the next question. It says show that the curve with equation this and the line with the equation that meet for all values of the constant k. Okay, now this is a little tricky. It's a question on quadratics, but it's a little tricky because I will show that is something different. Okay, what I have to show you is that if they meet means b square minus 4ac is greater than or equals to 0. Now I can't assume this. I have to show you that this is somehow being derived. Okay. Okay, this is somehow being derived. Okay, this is somehow being derived. Let's first put these equations together, solve them simultaneously and see what happens. I can substitute y equals to minus k minus 3x. So minus k minus 3x minus 40 equals to 0. So x square minus plus 3kx plus 9x square minus 40 equals to 0. So I get 10x square plus 3kx minus 40 equals to 0. Now what I want to show you is that the b square minus 4ac for this question is automatically always going to be positive, greater than or equals to 0 for all values of the constant k. What does that mean? Let's first filter that out. It's 3k square minus 4 times 10 times minus 40. Okay, plus this becomes 160 and then 1600. Okay, nice. That's 9k square. Sorry, 9k square plus 1600. Okay, not equals to 0. 1600. Okay, that is my b square minus 4ac. Okay, now b square minus 4ac is always positive because all values of k are being squared. In some cases at this point what you will have to do is you will have to complete the square as well. Here the square was completed. For example, I can say that this is 9k minus 0 whole square plus 1600. So regardless of the value of k that I plug in, this expression is always going to be greater than or equals to 0 or positive. Okay, so that's this question. You don't have to solve for a value of k. It's just about concluding that b square minus 4ac is greater than or equals to 0. The next question says the equation of a curve is such that dy by dx is equals to 4x minus 3 root x plus 1. Find the x coordinate of the point on the curve at which the gradient is 11 over 2. So 11 over 2, 4x minus 3 root x. Now you could treat this as it is Guy's quadratic equation and sort of take a substitution and then start solving. Or I think I'll be able to move this around a little and just square both sides and get to my final answer. Okay, so I can bring 3 root x to this side and this becomes 8x 1 minus 11, 8x minus 10. What I'm going to do is I'm going to square both sides and say that 9x equals to 64x squared minus 8 into 10 is 80 and into 2 is 160 plus 100. Okay, so 64x squared minus 169x plus 100. Okay, my ABC from here. Okay. I think I've missed a number. I have to restart this. So cross multiplying gives me 8x minus 6 root x plus 2. 6 root x is here, 8x minus 9. Then you square both sides. You get 36x, 64x squared, 9 into 8 is 72. 144x plus 81. 144 plus 36 gives me 180. So A, B, C. To write my quadratic formula, that's what I'm doing on my calculator. Let's see. 64 minus 180 and 81. So x is coming out as 9 over 4 and 9 over 16. Okay, two possible values. Find the x coordinate of the point. There's a single point, so what I will have to do is I will have to verify my original answers in this equation or in the equation below. So I'm going to first verify if 9 over 4 works. Okay, so 11 over 2, I can put this on a calculator and do this as well. 9 minus 3 times 3 over 2 plus 1, so 9 minus 9 over 2, 10 minus 9 over 2. So 20 minus 9 is 11 over 2, 11 over 2. So this balances. I'm pretty sure the other won't balance because this has to be the right, there's only one coordinate. I can show that to you. Okay. So 11 over 2 equals to 9 over 4 minus 3 into 3 is 9 over 4 again plus 1. Okay, so that's 11 over 2 equals to 1, not possible. So this one is discarded. Okay, given that the curve passes through the point 4 comma 11, find the equation of the curve. So let's try that again. Dy by dx is 4x minus 3x power half plus 1. Let's integrate 4x squared over 2, 3x power 3 over 2 over 3 over 2 plus x plus c. So y is 2x squared, and when this does the reciprocal, 3 divided by 1.5 is basically 2, 3 over 2 plus x plus c. 4 comma 11, so 11 4 plus c. 2 into 16 minus 2 into 11 minus 20 equals to c. That's minus 9. Let me check if that is the correct answer. Yes, that is the correct answer. So my equation of the curve is 2x squared minus 2x power 3 over 2 plus x minus 9. Okay. Then the next thing, circles C1 and C2 have equations this and that. Find the distance between the circles. Okay. So what I will simply have to do is find both the centers. I will the center is pretty clear. It says x minus 9 whole square plus y plus 4 whole square equals to 64. So the center is 9 comma minus 4 and radius is 8. Wait, let me just check with one thing. Okay, then for this one, I will have to complete the square. Let's first bring it into the right form and say that this is a square plus 2ab plus b square minus 18 plus 3 square and y square minus 2 times y times 5 plus 5 square plus 5 square. X plus 3 whole square, y minus 5 whole square. This gives me equals to 16. So the center is 3 comma minus 5 and the radius is 4. Okay. So what I want to find out is what is the distance between the two circles, 3 comma minus 5, and let's take the other circle with a different color. 3 comma minus 5. Minus 3 comma 5. Am I messing this up? Minus 3 comma 5. Okay, and 9 comma minus 4. So distance between the two circles would technically be just this. Let me draw this with a. Okay, the distance between the two circles should technically be just this distance. Okay, how am I going to find this? I'm going to find the distance between the two centers. I'm going to say that distance is minus 4 minus 5 whole square plus 9 minus minus 3 whole square. How was your exam, Saqib? 81 plus 154. 225, that's 15. And then 15 minus the 2 radii minus 8 minus 4, so that's 3. I think 3 should be the correct answer. Distance between the centers of the circles. Oh, okay. I thought distance between the two circles. Okay, so that's just this answer then. Okay, distance between the two centers of the circles, so that's the correct answer. P and Q are points C1 and C2 respectively. The distance between P and Q is denoted by Q are points in C1 and C2 respectively. The distance between P and Q is denoted by D. Find the greatest and least possible values of D. Okay, so Let's draw these a little more accurately, so we're going to see what we have to do for the greatest and least possible values. I know there are various ways to do it. You can involve a lot of differentiation, but that is not what I would recommend. Okay, so this circle is 9 and minus 4, so this one is on the left, minus 3 and 5, and this one is here, 9 and minus 4. Okay, C1, P and Q are somewhere on C1, C2, so that's C1 and that's C2. The distance between P and Q is denoted by D. Find the greatest possible and least possible values of D. Now, remember that regardless of whether you are involving the greatest or the least possible values, it must pass through the center of the circle, centers of both circles. Okay, because the diameters are both the longest straight line that you can draw inside a circle and the shortest distance that you can travel between the two edges of a circle. Okay, so if P and Q were here, that would be the greatest possible distance. What would then be? I know that the distance between these 2 points is 15. So the greatest distance is going to be simply 15 plus the radius plus the radius. Okay, that gives me 27. And the least is when P and Q are here and here. So least is going to be this. That's when they're on the edges. So 15 minus 4 minus 8, that gives me 3. Okay, that is the complete working for this question. You don't need to do anything else in this question. Question number 7, then the diagram shows part of the curve. The point A on the curve has coordinates 7 over 2 comma 6. Find the equation of the tangent to the curve at A, giving your answer in the form. So dy by dx is what I need to do. I'm going to bring this up first and say that this is power minus 1 over 3. So dy by dx will be minus 4 2x plus 1 minus 1 over 3 minus 1 is minus 4 over 3 into 2. Okay, that's the differentiation for this. I want to find the equation of the tangent. So at the curve at A has the coordinates 7 over 2, so minus 4. I can write 7 over 2, I can also write 3.5, that's what I'm going to write. Okay, let's put this on my calculator. Minus 4 into 8 power minus 4 over 3 and into 2. That gives me minus half y minus y1 mx minus x1. That's the equation. 2y minus 12 minus x plus 7 over 2. So 2y equals to minus x 7 over 2 plus 12 gives me 31 over 2. In the form y equals to mx plus c, so y equals to minus half x plus 31 over 4. Okay, yeah, that should be the correct answer. It says find the area bounded by the lines x equals to 0, x equals to 7 over 2, and y equals to 0. So y equals to 0 is that line. X equals to 7 over 2 is that line. So I'm asking you to find this area basically. So that's integrating with limits 0 and 7 over 2. So 12 2x plus 1 power minus 1 over 3 has to be integrated from 0 to 7 over 2 dx. Okay, I can pull the 12 outside, I can let it remain here as well. I have to increase the power by 1, that gives me the new power, that's 2 over 3. And I have to multiply with the differentiation of the bracket. And I have 0 and 7 over 2 here. Okay, so 12 divided by 2 over 3 divided by 2, 9. And the answer is 27. Yeah, 27 is the correct answer. Looking at the next question, it says it is given that beta is an angle 90 degrees and 180 degrees such that sine beta equals to A. Okay. Express tan square beta minus 3 sine beta cos beta in terms of A. Okay. Now, you've seen questions like this in the past papers, but this is basically K. This time it's not K, it's A instead. How do I convert sine beta into a value for cos beta? What I can do is, I know this identity that always stands true, that's sine square theta plus cos square theta equals to 1. So I can say that sine square beta is a square plus cos square beta equals to 1. Cos square beta will be 1 minus a square. Now, when I put a root, I need to decide whether it's positive or negative outside the root. Now, in this case, I'm in the second quadrant. In the second quadrant, only sine is positive, so cos should be negative, so there should be a negative outside here. Okay, that's cos beta. Tan beta would simply be sine a beta divided by cos beta. So a over root of minus 1 minus a squared. Let's fit all of this into this equation that I have here. So tan square beta minus 3 sine beta cos beta. So tan square beta was a minus root 1 minus a square into over square 3a and minus 1 minus a square. Okay, so this becomes a square, the negative becomes a positive and the root gets cancelled. So 1 minus a square, and this also becomes a positive, plus 3a root 1 minus a square. Okay. Yeah, I think I can't simplify this further, and that should be the entire answer. Yes, that is indeed the correct answer for this question. Walaikum salam. Okay, solve the equation. This sine square theta cos square theta equals to this. So I need to change this entire equation into sine first, because the other side has a sine as well. Okay, sine square theta plus 1. I'm just seeing if I've done the working correctly. Yeah, I think I've done most of the working correctly. Okay, then quadratic is 1, b is 4, c is 1 minus b plus minus root of b square minus 4ac over 2a. That on my calculator. 1, 4, and 1. I'm getting sine theta equals to minus 0.0227. Very small value. And sine theta equals to minus 43.9. Or no, I've done something wrong. Yeah. Okay, my bad. Very absurd values. That's minus 0.268 and minus 3.732. So this gets discarded because sine has to be between minus 1 and 1. Okay, I draw my quadrants here. So I am looking for sine is negative, so either in C or in T, alpha is sine inverse of 0.268. Sine inverse of 0.268 My calculator is in degrees. That gives me 15.5. Okay, quadrant 3 is theta equals to 180 plus 15.5. That's 195.5. Quadrant 4 is theta is equals to 360 minus 15.5. 344.5. Okay. Yeah, those are the answers. Surprisingly, a lot of marks for that. Okay, the equation of a curve is this. Find the set of values of it for which y decreases as x increases. So dy by dx is less than 0 then. It's a decreasing function. So dy by dx is 0 plus 5 plus 12x minus 9x squared. So 5 plus 12x minus 9x squared has to be less than 0. I'm going to use the quadratic formula again to first find two critical values, minus b plus minus b square minus 4ac over 2a. Five over 3 and minus 1 over 3. Minus 1 over 3 and 5 over 3. What values am I looking for? Looking for values from here that are greater than 0. So this one and that one. So x is less than minus 1 over 3 or x is greater than 3. Okay. Now you could have done this entire thing on a calculator. The calculator would have churned out this answer directly and that would have been perfectly fine too. You just have to make sure that you write this part. Okay, then it says it is given that y equals to this is a tangent to the curve. Find the value of the constant k. Okay. It's the easy way to do this then. I can't substitute it. It's going to create a cubic equation. Then I can't do much about it. I will have to use differentiation to do this. So dy by dx came out as 5 plus 12x minus 9x squared. I can't use this, do this using quadratics. Why? Because I can't solve a cubic and a linear simultaneously and expect to get a quadratic out of it. So you notice that this line has a gradient of 9. So at whatever point, dy by dx is 9. I can find that x coordinate. That is going to be the common point between this line and the other curve that I have. Okay, so what I can do is, let's first quickly find this. Again, I'm going to do minus b plus minus of b square minus 4ac. Nine minus 12 and 4. 2 over 3 or just one answer. That's 2 over 3. Okay, so that makes it obvious that it's a tangent. So x equals to 2 over 3. Now, if I want to solve here कि मैं यहाँ पे 9 and 2 over 3 लगाऊं, then I need a value for y. Where is that y value going to come from? It's going to come from there. Thank you, Shayan. Nice to see you here. Explain what again, beta? So I'm going to plug in x equals to 2 over 3 here. Eighty-two over 9, 82 over 9, and 3 plus k minus. I'm not sure if this is the correct answer, but let's check. Yes, that is indeed the correct answer. So what I've done is I've used the gradient of the tangent to find a value for x first. I've used that value of x in the equation of the curve that I had. Okay. Find a value for y, and then I've used that x and y in the line again to find the value of k. Okay, question number 10. An arithmetic progression has first term 5 and common difference d, where d is greater than 0. The second, fifth, and 11th terms of the arithmetic progression in that order are the first three terms of a geometric progression. Okay, so the second term, the term that I'm talking about is 5 plus d, 5 plus 4d, and 5 plus 10d. These three are the first three terms of a geometric now. Okay, find the value of t. Now there are two ways to do it. Either I could say that this is a equals to 5 plus d, then ar equals to 5 plus 4d, and ar square equals to 5 plus 10d. Now I don't like doing it like that, but I say that when you have consecutive terms in a geometric progression, what you can simply use is the concept of r. R comes out from term 2 getting divided by term 1. Okay, term 2 divided by term 1, or term 3 getting divided by term 2. Okay, and so on. If you had more terms, you could have done a further thing. You cross multiply 5 plus 4d whole square, 5 plus 10d into 5 plus d. 25 plus 40d plus 16d square, 25 plus 5d plus 50d plus 10d square. So that gives me 60 squared, that's 55, that comes here and makes it minus 15d, and I think 25 cancels out for 25, so equals to 0. So d 60 minus 15d, 16 equals to 0. Either d equals to 0, 60 minus 15 equals to 0, 60 equals to 15, and d equals to 15 over 6, which is 5 over 2. So that's the correct answer. Yes, that is the correct answer. Then the sum of the first 77 terms of the arithmetic progression is denoted by S77. The sum of the first 10 terms of the geometric progression is denoted by DG10. Find the value of S77 minus G10. We're talking about the same arithmetic and geometry, right? Yeah. So 77 over 2, 2a plus n minus 1, and d came out as 2.5. G10. The first term was 5 plus d, so 5 plus 2.5 is 7.5, so 7.5. 1 minus r. I don't have r. Let's go back and calculate r. R was just 5 plus 4d over 5 plus d. So 5 plus 4d over 5 plus t 1 minus r power n over 1 minus r. That gives me 10, 7.5. Okay. I haven't calculated a value for r. I'm just improvising with the calculations right now. So 15 over 7.5 is basically my r. So that's going to be 7.5, 1 minus 2 power 10 over 1 minus 2. And here I have 77 into 10 plus 76 into 2.5 divided by 2, 7,700. Yeah, 7.5 into 1 minus 2 power 10 by minus 1. I think I've messed up some calculation somewhere. Let me check. Oops, I did 77.5. Okay, 7672.5. 7. So answer is 7700 minus 7672.5. 55.2. 55 over 2, 27.5. That is the final answer for this question. Okay, moving on. The function f is defined by this, where f of x in the form this, where a and b and c are constants, and state the range of f. Okay, so first let's bring that into the required form. So that's going to be x squared minus 2cx plus c squared, a minus bx squared plus 2bcx minus bc squared. So arrange this and arrange that as well. So minus bx squared plus 2bcx plus a minus bc squared. So minus b equals to minus 2, therefore b is equals to 2. 2bc is equals to 6. 2 times 2 times c is equals to 6. C is equals to 6 over 4, which is 3 over 2. Let's call that 1.5. And 3 equals to a minus bc squared. So a, b, and c squared. So 3 minus 3 plus 2 times 1.5 squared is 7.5. So a is 7.5. Okay. So this comes out as 7.5 minus 2x minus 1.5 whole square. The turning point from here is 1.5 comma 7.5. This looks like a sad face curve to me because minus 2x square 1.5 comma 7.5. So the range has to be y is less than or equals to 7.5. Okay. Isn't that what I'm doing right now? Okay, the function g is defined for x is less than or equals to 0. Sketch the graph of y equals to g of x and explain why g is a one-to-one function. You're not required to find the coordinates of any intersections with the axes. Okay, so it's starting from 0 now. Instead of starting from 1.5, it's starting from 0. So let's find out where it is at 0. Oh, okay, I missed out a question. Let's first do this. The graph of y equals to f of x is transformed into the graph of y equals to h of x by reflection in one of the axes followed by a translation. It is given that the graph of y equals to h of x has a minimum point at the origin. Give details of the reflection and the translation involved. Okay, so in one of the axes, so I will have to do a bit of trial and error and sort of conclude whether what axis it would be. Right now the turning point, the coordinates are 7.5, 1.5 comma 7.5, and they go down to 0 comma 0. So if this was a translation such that minus f of x, which means that it was a translation with x-axis as the reflection line, as the line of reflection, then what would have happened is your y coordinate would have changed. It would have become minus 7.5. In that case, the translation that you would require then is you would need to come back 1.5 units and go up 7.5 units, and that should be your final answer. Okay. Okay, in case you did the other way around in one of the axes, so in that case your x coordinate would have become minus 1.5. Okay, no, it has a minimum point. That means that it was definitely a reflection in the line in the x-axis. Why? Because a maximum point will only change into a minimum point only when you have a reflection in the x-axis. Okay, so this curve has to become this curve. That is the only way that I could have a minimum point. So there was a trick to the question that I hadn't noticed earlier. Okay, then it says that now you need to sketch this curve with 0 as the starting point. So g of x equals to 3 plus 6 times 0 minus 2 times 0 square. That gives me 3. So what am I going to say? That I'm going to say that this curve starts from 3, 1, 2, 3, and it's going to go like down like that. Okay, and g is a one-to-one function because it does not turn. Okay, because it does not turn, and the market gives something else as well. Okay, now you need to be more precise. It says for each value of x, there is exactly one value of y, and there is only, and for each value of y, there is exactly one value of x. Okay, the turning point definition might also work since marking schemes are a little vague when it comes to writing down explanations. Here's the graph of y equals to g of inverse of x on your diagram in C, and find an expression for g inverse of x. Okay, you should label the graphs in your diagrams appropriately. So that was g of x. For g inverse of x, I will need the point coordinates. Now 0 comma 3 becomes 3 comma 0. Okay, and I will need the line y equals to x. I'm going to draw that here. Okay, and that curve is going to look like that. The inverse of x. Okay, then g inverse of x for g inverse of x, you will have to start with the completed square form. That was 7.5 minus 2 times x minus 1.5 whole square. Okay, so y 2x minus 1.5 squared, 7.5 minus y minus 1.5 squared, 7.5 minus y over 2, take a root. Now you have to decide whether you want a positive or a negative answer outside the root. That's how you decide using, and that's what you decide using the part of the graph that's present. Part of the graph that's present is before the turning point. So I'm going to take a negative outside the root and say that this is minus 7.5 minus y over 2. Okay, so 1.5 minus 7.5 minus y over 2. Okay, I'm going to write an x there. Yep, that is the correct answer. Although you can't write a fraction over a decimal, so that's something that you need to be worried about. You should write all of this as then a fraction, 3 over 2 minus 15 over 2 minus x over 2. Okay, and then simplify this, so this becomes 15 over 4 minus x over 2. The best answer would be this. Umar in a bit. Okay, yeah, that is the end of this exam. I can explain to you one question 11. One, two. Okay, I think I'll have to open this up. Okay, this question, it says a function is defined by this f of x, find the set of values of x for which is decreasing, so dy by dx is less than 0. Let's calculate dy by dx. Minus 12x power minus 4 plus 3x power minus 2 plus 2 plus 0. Okay, now I had to solve for what? I had to solve for find the set of values of x for which this is decreasing. Okay. So minus 12x power minus 4 plus 3x minus 2 is less than 0. So x power 4 in the denominator. This gets cross multiplied, so I have 3x squared minus 12 is less than 0. You could solve this with a quadratic inequality, or I can show you something directly as well. You can do this, but this is certainly not recommended. But when you put a root on both sides, it generates two answers: x is less than 2 or x is greater than minus 2. And you introduce a negative, you need to flip the sign as well. So that's the set of values of x. Then it says the triangle is bounded by the y-axis, the normal to the curve at the point where x equals to 1, and the tangent to the curve at the point where x equals to minus 1. Find the area of the triangle. So what you need to do is first you need to find the normals and the tangents. So dy by dx was minus 12 over x power 4 plus 3 over x squared. First at the point 1, so dy by dx at x equals to 1 is minus 12 over 1 plus 3 over 1, that's minus 9. Normal is then 1 over 9, and the equation would be y minus y1. Okay, what are the points x1 and y1? 1 over 9 x minus 1. If you plug in 1 into the curve, you get 4 minus 3 is 1, 1 plus 2 is 3, y minus 3. So this becomes 9y minus 27 equals to x minus 1. 9y equals to x plus 26. Okay, that's the normal. And that line looks something like this. If I were to draw this, it's going to look something like this. Okay, because it's not a tangent, it's a normal, it's perpendicular to this tangent. Okay, then at minus, I want another line that is dy by dx at x equals to minus 1. So that would give me minus 1 power 4 plus 3 over minus 1 square. That would also give me minus 9. This time I want the tangent. So let's find out the y coordinate. Y equals to 4 over minus 1 cubed minus 3 over minus 1 squared. That was just minus 1, 3 over minus 1 plus 2. So that gives me minus 4 plus 5 is 1. So that point is somewhere here. Okay, let's imagine that to be here, a little below that or somewhere like that, and that's the tangent that I'm looking at. Okay, what do I want to find out? I want to find out the area by the y-axis, the normal to the curve, and the tangent to the curve at the point where x. I'm looking for this. That's the area that I'm looking for. Okay, so I could certainly find out this coordinate. What's the y-intercept? What's the y-intercept? It's 26 over 7. Find out this y-intercept. So y minus y1 mx minus x1. Looks like minus 8. Okay, and the intersection points of these. Okay, how do I find the intersection points? I solve them simultaneously. Minus 4 plus 23 over 41. Let me check if I am doing this right. Okay, 23 over 41 नहीं है, sin x minus 8 minus 49 over 41. This is coming out as positive. I think I've done a calculation mistake somewhere. Okay, this is minus 72. So 26 plus 72, 98. So minus 49 over 41. That's the x coordinate. The y coordinate will also look something like this. This is weird. 9 times minus 49 over into 41 minus 8 minus 8. So the y coordinate is something like minus 769 over 41. Now the area is going to be something like this. It's 26 over 7, 26 over 9, not 7, 26 over 9. Okay, 26 over 9 and up till 8, that's your base and that's your height of the triangle. So half base is basically 26 over 9 plus 8 and height is 49 over 41. Okay, so let's see what you get. 26 over 9. That's a really weird calculation. I've never seen calculations like that. Wait, 2401369. That gives me 6.51. Yes, that is the correct answer. So tough question at the end for June 24. Okay, whoever was asking, that's your answer. Okay, that's the end for today's live stream. Thank you.